I'd like to show you a great context for STEM exploration that requires few materials and has broad implications. What we have here is a couple of soda bottles that we've taken the bottoms out of and jammed them together, put them together just by cutting one a little short of the bottom so that it's a bit of an angle, and just jammed it in there. And what I've done is put just a little tape so that if there's any air that might escape, we can capture most of it. I made a boat that kind of fits in the middle. It's a piece of cardboard that fits in the middle of this piece of plastic, and I used some foam, some little cuts out of a foam tray, and glued them to make a tray so that we can place whatever we like in this tray. And on one end I put a little block of wood, hot glued a hobby motor and a simple reasonable fan on the hobby motor, such that when I turn on a battery source and the fan and put in a meter, I can actually create a fan and create flow to go through here. So the idea is we're creating a wind draft that will go through and go over our materials here through this tube, and we can actually see how much air there is. If you have a simple anemometer, you can attach a simple anemometer to the end, and in my example here, we're getting about 1.1 miles per hour or so. So in this wind tunnel, we could actually calculate how much total air was going through, and ultimately, as we think about how this is going to be warmed by the sun, we could figure out how many BTUs and how much caloric energy is given to the air. Well, to actually make this work, what I do is take it out in the sun, but for lack of sun indoors, we have a little lamp, and this is just a simple little heat lamp. Actually, this is just a 100-watt bulb. You can use a heat lamp, which would be a lot more energy, but in this case, I'm going to measure the input temperature on one side of our little air draft here, and just put a thermometer on the intake, and do the same thing for the outflow. Put a thermometer on the other side. And what's great about this is that we can monitor this progress of input versus outflow and graph the results over time. So the heat from the heat lamp, of course, is being captured by, and we just selected in this case some marbles, some black marbles. The black marbles are absorbing the heat. The air is passing over the black marbles, acquiring some of that heat, and then transferring it to the end of the tube, such that we have about an input temperature of somewhere around 20 degrees Celsius and an exit temperature somewhere around 30 degrees Celsius after a few minutes of operation. The clear implications, of course, are solar energy. How can we understand how much energy we are creating here by this solar receiver, and then how much air can be pulled across. The reason I have an ammeter in the circuit and we're measuring how much current is being drawn is because we're interested to know if we are using a certain amount of electricity to blow air, and we're actually using and getting energy from the sun through this process, what's the trade-off? In other words, if I was going to have to buy BTUs made out of oil or gas or electricity, how much would it cost me per BTU versus how much electricity am I using in this system right here? The other possibility, of course, is to use and support a solar battery instead of a regular 2 cells that I have over here, in which case we'd need to know I've got 3 volts and 1.2 amperes of draw, and so whatever solar cells I would need to find would have to have at least that energy delivering capability. So then the passiveness of requiring energy for the system is then exhausted once you've paid for the initial cost of the solar battery. Well, we can figure out with the volume of air how many thermal units are being produced. We can figure out a number of things about the energy production in this system. The next thing that, of course, is interesting for the STEM aspects of the science content is why did I choose marbles? Could I choose lead balls, or could I choose rocks, or could I choose some other material? And of course, what we can explore here is what material would be the best to absorb the heat, to hold the heat. Because after we turn the electricity or the sun off, we would be interested to know how long we could continue to take heat from these hot rocks, so to speak, or hot marbles, and how long and how can we graph the gradual drop in temperature such that in the evening could we capitalize on still the repository of heat in this solar reserve. So lots of wonderful exploration, lots of variables in terms of what we could put here, and if you go to the Ventures site you can see the additional kinds of activities and explorations one might do with a solar boat as we've created here.